The hiring algorithm was supposed to take human bias out of the process. And somehow, it did the exact opposite. Here's the story. A big tech company built an AI tool to screen resumes. The pitch was simple: train it on about 10 years of past hiring decisions, teach it what a successful candidate looks like, and let it reliably surface the best applicants. Faster, cheaper, more consistent. And, on paper, more objective. But the system wasn't objective. Because the data it learned from wasn't objective. That decade of hiring decisions already reflected a decade of real-world human judgment. And those judgments had favored men for technical roles. So the model did what machine learning does: it picked up the strongest patterns and reproduced them. Faithfully. It started penalizing resumes containing the word women's, like women's chess club captain. It downgraded graduates from a couple of all-women's colleges. And when the engineers tried to fix it by removing gender signals, the model just found other routes. Language patterns. Activities. Experience clusters. One proxy disappears, another one pops up. Eventually, they abandoned the system. Not because the team wasn't capable. They were. But because they ran into a hard truth: when an AI learns from biased history, bias is not a bug. It's a feature the model optimizes right into the center of its logic. And here's the scary part. A biased person might impact the candidates they personally interview. A biased algorithm impacts everyone it touches, every single time, at massive scale, wrapped in this comforting illusion that math is neutral. But models aren't neutral. They're mirrors. They reflect patterns in the data we give them, including the patterns we wish weren't there. Today, we're digging into AI bias, why it happens, why it's so hard to spot, how you measure it, what it looks like to actually prevent it, and what organizations must commit to if they want fairness to be real, not just aspirational. I'm Nakel Nikiema, and this is the Intelligence Edge. Alright, joining me today is a 4-guest panel who see this from different angles: technical engineering, governance, ethics and compliance, and the strategy side of responsible AI in the real world. Dr. Lian Zhou is an APAC AI transformation expert who's helped organizations roll AI out across different markets where culture and context can change what harm even looks like. Dr. Zhou, welcome back.
Thanks, Nakel. Bias is one of the biggest AI risks we have, not just for companies, but for society.
Maria Alvarez is a data governance leader. She's spent years in the uncomfortable place where everyone wants fairness, but nobody wants to do the hard work of data quality, access, and measurement. Maria, great to have you.
Happy to be here. And yes, bias is a data problem and a measurement problem before it's anything else.
Jonas Richter is a data ethics and compliance specialist, deep into discrimination law, fairness definitions, and the ethical foundations behind what we call equitable AI. Jonas, welcome.
Thanks, Nakel. In a lot of ways, this is the ethical core of deploying AI responsibly.
And Kwame Mensah is an intelligence systems architect. He builds systems where bias mitigation is designed and engineered into the stack, not treated like a press release after the fact. Kwame, good to have you.
Glad to be here. This is where good intentions collide with real engineering constraints.
Let's start at the foundation. When people say AI bias, it can sound like one thing. But it's not one thing. Kwame, where does bias actually come from?
Yeah, it's helpful to break bias into sources, because the fix depends on the diagnosis. The first source is the obvious one: bias training data. If the historical record contains discrimination, the model learns discrimination. It's not broken, it's learning patterns correctly. Second source is unrepresentative data. If you don't have enough examples of certain groups, performance drops for them. Classic example: facial recognition trained mostly on lighter-skinned faces tends to do worse on darker-skinned faces. That's not the model deciding to discriminate, it's the data distribution. Third is proxy variables. Even if you remove race or gender, the model can use other signals that correlate. Zip code can map onto race. Certain extracurriculars might correlate with gender. Remove one proxy, the system often finds another, exactly like that resume filtering story. Fourth is biased labels. If the label you train on is already a biased judgment, like good employee, high performer, creditworthy, then the model learns a biased definition of success. It's learning your label logic. And fifth is feedback loops. A model's outputs change reality, and then that changed reality becomes future training data. So the bias compounds. If you predict someone is high risk and deny them opportunity, you can create the conditions that confirm the prediction later.
So there's no single lever. It's more like a system of pipes feeding bias into a model.
Exactly. And those sources behave differently. You can't treat proxy bias the same way you treat underrepresentation. You have to know what you're dealing with.
Dr. Zhou, that cold open hinted at it, but say it plainly. Why does algorithmic bias often feel more dangerous than human bias?
3 big reasons. First is scale. A biased person influences a limited number of decisions. A biased model can influence millions. So one flawed system can produce harm on a scale that no individual could. Second is consistency. Humans are inconsistent. They might reconsider, be challenged, be corrected. An algorithm applies the same logic every time. If that logic disadvantages a group, it disadvantages them with perfect reliability. And third is what I call the objectivity illusion. People are suspicious of human bias, but they tend to trust machine outputs. The system decided sounds scientific. That makes the bias harder to challenge, and it can persist longer without being questioned.
Right, it's like bias with better branding.
Yes. The same discrimination, but with an aura of neutrality.
Maria, you've said bias is a measurement problem. Why is it so hard to detect in practice?
Because bias often masquerades as performance. That hiring model looked like it was doing great if your only question was, can it predict who we historically hired? And it probably could. The bias shows up when you ask a different question. Were those outcomes fair, and are we repeating unfairness? Most teams rely on accuracy metrics, precision, recall, AUC, whatever is standard. None of those automatically tell you whether one group is being treated worse than another. You can have a model that's high-performing overall and still creates large disparities. To detect bias, you have to measure fairness across groups on purpose. That means deciding which groups matter, having data on group membership, picking fairness metrics, and deciding what gap is acceptable versus unacceptable. None of that happens by accident.
And the punchline is, if you don't measure it, you won't see it until it's a headline.
That's usually how it goes.
Jonas, bring us into the ethics and legal side. In a world where, the algorithm said so, is a common excuse, what does the landscape actually look like?
The headline is, algorithms don't get a legal pass. Anti-discrimination laws generally apply whether a human made the decision or a system did. Saying the model decided is not a defense. That creates real liability, especially for high-impact domains like hiring, lending, housing, education, healthcare. If an AI system causes discriminatory outcomes at scale, you can be amplifying illegal discrimination at scale. Ethically, it goes deeper than compliance. Because fairness isn't one simple thing. There are multiple definitions, and they don't always agree. And then there's the question of historical injustice. Should an AI system reflect the past, or should it actively counter patterns that harmed people? Regulators are also moving. The EU AI Act, for example, treats many of these uses as high risk. The direction is clear. Companies will increasingly be expected to demonstrate fairness, not just claim it.
Which brings us to what you just mentioned, fairness isn't one thing. Segment 2, the fairness paradox. Jonas, why isn't just make it fair a straightforward request?
Because fair has multiple mathematical definitions, And in many real-world settings, you can't satisfy them all at once. That's not a tooling gap. It's a fundamental incompatibility that shows up when groups have different base rates, often due to historical inequities. Let me lay out 3 common fairness notions. One is demographic parity. You want selection rates to match population proportions, so outcomes look equal across groups. Another is equal opportunity. Among qualified people, different groups should have equal chances. This focuses on treating equally qualified individuals the same way. A third is predictive parity. If the system predicts someone is qualified or high risk depending on the domain, then that prediction should be equally reliable across groups. When base rates differ, you typically can't get all 3 at once. Improve one and you often worsen another. So make it fair is not a complete specification. It hides a values choice.
So the paradox is, fairness is a requirement, but it can't be maximized in all directions at the same time.
Exactly. And someone has to choose what kind of fairness matters most in this context.
Dr. Zhou, if fairness is partly a values decision, how do organizations navigate that without turning it into chaos or politics?
By treating fairness like a deliberate decision, not an implicit default. First, make the choice explicit. Don't let your fairness definition be whatever the optimization happened to produce. Second, make it contextual. Hiring is different from fraud detection. Lending is different from healthcare triage. The right fairness lens depends on the type of decision and the harm you're trying to prevent. Third, involve stakeholders, especially people affected by the system. If you define fairness without input from those impacted, you often miss what actually matters. And fourth, be transparent. Not necessarily exposing every line of code, but being clear about what fairness goal you chose and why.
Kwame, translate that into engineering reality. What happens when leadership says, we want fairness, and engineering says, okay, define it?
That's the moment everything gets real. Engineers like crisp specs. Make it fair isn't a spec. Optimize for equal opportunity across these protected groups, and accept that demographic parity may not hold is a spec. So what we do is surface trade-offs. We show decision makers, if we tune the system this way, here's what happens to selection rates, error rates, and outcomes across groups. If we tune it that way, here's the alternative. And then we force an explicit decision. Not in a gotcha way, just honestly. Someone accountable has to say, this is the fairness objective we're choosing. Only then can engineering implement and monitor the right thing.
Maria, where does governance come in? Because if this stays informal, it turns into a hallway conversation that nobody owns.
Governance is how you prevent the nobody owns it problem. You need a structured fairness governance process. First, ownership. Someone has to be responsible for the fairness definition decision for each system. Second, consultation. Affected stakeholders should have a way to provide input, whether through representative groups, advisory panels, or a formal review. Third, documentation. Write down the fairness definition you chose, why you chose it, what trade-offs you accepted, and who you consulted. That record matters later, for accountability, audits, and learning. Fourth, approval. For high-stakes systems, the fairness decision shouldn't be buried in a team. It should be reviewed at the right level. And fifth, reassessment. Fairness isn't a one-and-done checkbox. You revisit it as outcomes and context change.
Segment 3, Detection and Measurement. Let's make it practical. Kwame, if a team says, we want to detect bias, what do they actually do step by step?
Think of bias detection as a measurement workflow. Step 1, decide which protected groups you're assessing. That might include gender, race, age, disability, depending on the domain and region. Step 2 is the hard part. You need data on group membership to measure differences. A lot of organizations don't collect it, or they're uncomfortable collecting it. But if you can't see group-level outcomes, you can't quantify fairness. Step 3, pick the fairness metrics that align to your fairness definition, demographic parity, equal opportunity, predictive parity, or others. Step 4. Run your model and compare outcomes and error rates across groups. Who gets selected? Who gets rejected? Where do false positives and false negatives concentrate? Step 5. Test for proxy behavior. Even if you remove protected features, check if disparate impact still appears. If it does, your model found other signals. And Step 6. Intersectionality. Bias can be worse at intersections, like older women, or younger men in a certain region. If you only check one attribute at a time, you can miss compounded harm.
I want to underline something you said. Removing sensitive attributes doesn't mean bias is gone. It can just go underground.
Exactly.
Maria, you've called it a governance paradox. To detect bias, you often need demographic data. But collecting demographic data can create privacy and legal concerns. How do organizations manage that without making things worse?
You handle it with strict purpose and protection. First, purpose limitation. If you collect demographic data, the reason should be explicit, fairness measurement, so it can't be quietly repurposed. Second, privacy controls. Strong access limitations, aggregation where possible, anonymization where appropriate. Treat it as sensitive data, because it is. Third, legal compliance. Some places restrict collecting certain demographic attributes, while others expect fairness evaluation. You need counsel and clear policy. Fourth, transparency. People should understand why you're collecting it. We collect this to check whether our system treats groups fairly, is a legitimate and explainable reason. And fifth, separation. Ideally, the model doesn't use protected attributes for decisioning, but you keep them in a separate channel for auditing fairness.
So it's not collect nothing or collect everything. It's collect what you need, protect it aggressively, and constrain its use.
That's the balance.
Dr. Zhou, how often should teams be doing this measurement? Once before launch? Every quarter? Every retrain?
It has to be ongoing. First, because models drift. Retraining on new data can create new bias or amplify existing bias. Second, because the real-world population changes. The system might serve different groups over time, or new dynamics emerge. And third, because we learn. What you consider important fairness dimensions or acceptable disparities might evolve. So you want thorough checks pre-deployment, continuous monitoring in production, and triggered reviews when you retrain models or change data sources, plus periodic deep reviews even if nothing seems wrong.
Jonas, say a company detects significant bias. What then? Because detection is the easy part compared to what comes next.
Detection creates an obligation. The ethical response depends on severity and stakes, but there's a general order of operations. First, assess harm. Who is affected and how serious is it? A small disparity in a low-impact recommender system is different from discriminatory hiring, credit, or housing decisions. Second, consider suspension. If it's high stakes and the bias is significant, the ethical default might be to pause the system while you fix it. Operating a system you know is harming people is difficult to justify. Third, remediate quickly and verify that the fix worked. Fourth, address past harm. People impacted in the past may need recourse. Review of decisions, corrective action, acknowledgement. And fifth, prevent recurrence. Find out how it happened, data, labels, governance, and make sure the same failure mode isn't waiting in your next project.
Segment 4. Prevention and Mitigation. Kwame, when you're brought in to actually fix bias, what techniques are available that genuinely work in practice?
I group them into 3 stages: before training, during training, and after training. Before training, you can work on the data. Rebalancing is common, adding data for underrepresented groups, reweighting, resampling. You can also relabel if the labels encode biased judgments, though that can be hard and expensive. And you can remove certain features, but as we said, proxies can still sneak in. During training, you can add fairness constraints directly to the optimization. So the model can't get its accuracy by creating disparities beyond a threshold. Another technique is adversarial debiasing, training a model so that protected attributes can't be inferred from internal representations or outputs. After training, you can adjust outputs. For example, tuning decision thresholds by group to meet a chosen fairness metric. Or calibrating outputs so the scores behave more consistently across groups. And none of these are free. You usually trade some pure accuracy or efficiency for fairness. But in high-stakes areas, that trade is often worth it.
Dr. Zhou, mitigation is what you do after the system is already on the tracks. But what does prevention look like? How do you stop the bias before it enters the pipeline?
Prevention starts much earlier than model training. First, diverse teams. Homogeneous teams have blind spots. People notice issues that touch their lived experience. Diversity reduces the chance that obvious harm goes unseen. Second, fairness by design. Don't build the model and then hope you can patch fairness onto it later. Make fairness a requirement from day one. Third, problem framing. If you frame your goal as replicate historical hiring, you lock historical bias into the objective. If you frame it as identify future success with careful definitions, you have a shot at a fairer target. Fourth, scrutinize your data up front, where it came from, who it represents, what patterns it contains. And fifth, involve stakeholders early. People affected by these systems often see risk that builders miss.
Maria, how do you make sure all that actually happens? Because we care about fairness doesn't automatically change the development lifecycle.
You embed it in the lifecycle as requirements, not suggestions. At project kickoff, you require a fairness risk assessment. You require an explicit fairness definition decision. You require thinking about team composition. During data prep, you require bias analysis of training data, representativeness checks, and documentation of where data came from. During development, fairness metrics sit next to performance metrics, and bias testing is required before deployment approval. Before launch, you require sign-off on fairness assessment, documentation of the decisions and trade-offs, and a monitoring plan. And in production, you require continuous fairness monitoring, clear response protocols, and periodic reassessment. That's how fairness becomes part of how we build, instead of something we remember at the end.
Jonas, talk transparency. People often say, we can't explain the model, or we can't reveal details. What role does transparency actually play in fairness?
Transparency is a foundation for accountability. If nobody can see what fairness goal you chose, how you measured it, or how you respond when it fails, then nobody can hold you responsible. It also enables contestation. If a person is denied a job or a loan by an automated system, they should be able to ask why and challenge the decision. Without meaningful transparency, that's impossible. Transparency also builds trust, and it helps the broader field improve. Organizations learn from each other's approaches. Now, I agree there are limits. You don't have to publish proprietary code or create a playbook for gaming the system. But you do owe people meaningful transparency. What fairness means here, how you measured it, what controls exist, and what recourse is available.
Segment 5, the organizational commitment. Because at a certain point, bias isn't just a modeling issue. It's a leadership issue. Dr. Zhou, what does real commitment look like versus performative commitment?
Real commitment shows up in costly choices. First, resources, time, people, tooling, data. If it's underfunded, it's not real. Second, willingness to accept trade-offs. Fairness can cost accuracy, speed, or revenue. If leadership never accepts any cost, then fairness will always lose. Third, incentives. If teams are rewarded only for shipping and performance, fairness becomes a nice-to-have. If fairness is in evaluation and incentives, it becomes real. Fourth, empowered advocates. People need permission and power to raise concerns, and sometimes to stop a deployment. And fifth, the moment of truth. What happens when bias is detected? Do you fix it, pause it, own it? Or do you rationalize it and keep going quietly? That's what separates commitment from theater.
Maria, what does that look like structurally in a governance setup?
Governance needs teeth. The fairness function needs actual authority to block or pause deployments when requirements aren't met. It also needs independence. If the same group building the model is the only one approving its fairness, you have a conflict. Independent review builds credibility. And, again, resources matter. If you assign fairness work to one person part-time with no tools and no access to data, then it's just optics. You also need escalation paths, up to senior leadership and sometimes the board, for high-impact issues. And there must be consequences when fairness requirements are ignored. If nothing happens when rules are violated, they're not rules.
Jonas, connect this back to values. Because companies love saying they value fairness.
AI systems force values to become operational. It's easy to say we treat people with dignity. It's harder to encode what that means when you're deploying models that influence opportunity. So AI fairness becomes a test of whether values are real. If an organization's stated values conflict with its deployed systems, the system reveals the truth. And there's also a broader societal question. Do you accept historical inequities as data? Or do you decide you want to counter them? That's not a math question. It's a moral and strategic one, and leadership has to answer it.
Segment 6, the tactical edge. Let's bring it home with concrete actions leaders can take this week. Quick hits. Dr. Zhou, go first.
Pick your most consequential AI system, one that affects people's opportunities. Ask, have we measured fairness across groups, or did we only measure accuracy? If you only measured accuracy, you don't actually know if it's biased. That's your starting gap.
Maria.
Ask whether you have the data needed to detect bias. Do you have group membership data, collected and protected properly, so you can measure fairness across populations? If you don't, you're effectively blind.
Jonas.
Identify who owns the fairness definition for your key systems. Has your organization explicitly chosen what fairness means in this context? Or did you let the model's default optimization quietly define fairness for you? If it was never explicitly chosen, you have a governance and values gap.
Kwame, bring us home.
Take one system and test for proxy discrimination. Even if you remove protected variables, check whether outcomes still differ significantly across groups. If they do, the model is using proxies, which means your mitigation is likely superficial.
All right. Let me synthesize what we covered. AI bias doesn't come from one place. It can come from biased historical data, missing representation, proxy variables, biased labels, and feedback loops that compound harm. And it can be more dangerous than human bias because it operates at scale, with consistency, and with this seductive illusion of objectivity. We also talked about why bias is so hard to detect, because it can look like success. A model can be accurate while faithfully repeating unfair patterns. You only see the problem when you measure fairness across groups deliberately. The fairness paradox is real. Different definitions of fairness can conflict, so make it fair is not a complete instruction. Organizations must choose what fairness means in their context, and that choice is a values decision as much as a technical one. Detection requires systematic measurement, access to the right demographic data with strong privacy protections, and continuous monitoring, not a one-time audit. Mitigation can happen before training, during training, or after training, but prevention is always better. Diverse teams, better problem framing, fairness by design, and stakeholder involvement. And ultimately, fairness is not something you hope for. It's something you engineer and govern. Real commitment shows up in resources, in incentives, in empowered oversight, and in what you do when bias is discovered. That resume filter that learned to discriminate wasn't a weird technical glitch. It was a mirror held up to biased history. The question for every organization is whether your AI will reinforce the patterns you inherited, or help build something more just. And that's not a question math can answer. It's a question you answer with decisions, governance, and code. Dr. Lien Zhou, Maria Alvarez, Jonas Richter, Kwame Mensah, thank you for the conversation.
Thank you, Nakel.
Great discussion.
Really important topic.
Always glad to dig into the real details.
Next week on The Intelligence Edge, AI for Finance, the Intelligent CFO. We're kicking off a domain series on how AI changes financial leadership, forecasting, analysis, risk, and strategy. Until then, I'm Nakel Nikiema. Make better decisions.